Hi friends, welcome to the Unit 3 Day 3 notes. This one we've been using the rational zeros theorem to essentially factor out a polynomial completely. This example for number 8, I ran out of time in the last video, so I really wanted to not feel rushed. So again, we're going to list all the possible rational zeros. Notice that we don't use all of the rational zeros and that they're just the possible ones. They're not all of them. So in this case, it's the factors of 12 over the factors of 1. So this is going to be plus or minus 1, plus or minus 2, 3, 4, 6, and 12. So those are all my possible ones. I'm going to grab my graphing calculator. I'm going to go ahead and graph the that equation. So x to the 5th minus 3x to the 4th plus 3x cubed minus 5x squared and then plus 12. Let's go ahead and graph it. All right. So here's our instance. We're going to see a bounce. That bounce is actually going to affect the multiplicity. Looks like from this graph, I only intersect it, or touch it even, twice. So that's going to be kind of an issue. That bounce is going to actually be another multiplicity. So we're going to find that. So let's first figure out if we can use our graphing calculator to find any of the zeros first. Yep. So I have a 0 at, no comma yet. I have a 0 at -1. So that helps with one of them. Second calc. By the way, I hit catalog instead of the wrong thing, so I need to go back to the graph. There we go. 0, left bound, right bound. Let's see what happens. Okay. This one, a lot of students will be concerned about getting a value like this when you get a 0. This is at x equals 2. Your y value is 0. Even though it doesn't look like it looks a little off, it is still at 2. The reason the calculator is having issues with this is because this is a bounce, and it bounces near that. So it actually plugged in that x value. Your calculator is plugging in a bunch of different x values, and it gets really close. And we're going to see kind of what happens here when we plug in 2. So I'm just going to make a note. 2 was special. I'm going to make a note of that when we go back into using synthetic division. So let's use synthetic division. I'm going to use -1 first. So when I use that, I've got 1x to the 5th, -3x to the 4th, 3x cubed, -5x squared, 0x, don't forget, you need to account for that, and 12. Bring down the 1, -1, -4, 4, 7, -7, -12, +12, +12, -12. Ooh, looking dicey there for a bit. And then now I'm going to plug in 2, use 2 with synthetic division. Bring down 1. 1 times 2 is 2. -2, -4, 3, 6, -6, -12. All right. So this gives me, again, this is started as a 5th degree, 4th degree, so this is a 3rd degree. So this is going to be x cubed minus 2x squared plus 3x minus 6. Looking at this, it looks like it's a nice factor by grouping with what we have left. So I factor by grouping, let's see, if I factor out an x squared, I'm left with x minus 2. If I factor out a 3, I'm left with x minus 2. So now I have x squared plus 3 and x minus 2. This is nice that it's already factored, like we've already factored this down to this. And then I also know that I have my zeros also at -2 and then at 2, or sorry, -1 and 2 as well. So if I include those in this, then I'm going to have x plus 1 and then x minus 2 also. So there's a few things to note. The first thing is that this one, if I solved for this value, if I found the zeros for this, I'm going to end up with imaginary numbers. So if I minus 3 on both sides, I have x squared equals -3, square root, plus minus. So I have x equals plus or minus I squared root of 3. So that's another one of my zeros. And then also I had a multiplicity of 2 because I had this x minus 2, I had that twice. And that's why you saw it bounce on the graph. When you have a multiplicity that's even value. So whether it's 2, 4, 6, 8, whatever, you will see it bounce on the graph. And that's why we had some issues with that earlier. All right, sorry about that. That was a weird jump that you just had, and that was because my disk space was full of my computer, so I had to go back and delete some old videos. I apologize for that. So what we're talking about here is that we had the multiplicity of 2 with 2, so that's why we have that twice. We have these imaginary solutions as well. So we have plus or minus I square root of 3. So this is also, so I have all of my zeros. I have 1, 2, 3, 4, 5 of my zeros, and notice my degree of my polynomial is 5 as well. When I write it in completely factored form, this is how I would notate it because of this x, because of the x squared plus 3, x minus 2, x plus 1. What I can do though is I can combine the x minus 2's to make it x minus 2 quantities squared, and then x plus 1. And that is the polynomial completely factored out and the list of my zeros. Thank you for joining me in Unit 3, Day 3 notes. I hope you have a wonderful day. Bye.